So welcome, you're watching lesson 3, which is vectors part 2. And what I wanted to do is actually go over the worksheet that's going to be for your homework, because I think it kind of does a good job teaching you what I want you to know. So with this one, you're going to notice that this is not the exact same one that you have. Some are similar, but I changed them up a little bit just so we could, I can actually test you in whether or not you know how to do this. So what we have here is a bunch of vectors. We have vectors A, B, C, D, E, F. We have this red one that's going to represent our resultant. For A, B, C, D, E, and F, we're not going to change how those arrows are. So we're not going to stretch them out or anything. The red one, however, right here, we are going to be changing that one to fit our resultant. So problem number 1 says, add up the following vectors by moving them. Be sure not to adjust their sizes or directions. The red one is for question 2. So we have, notice it's A plus C, so there's no B in this one, plus F plus D plus C, and there's some directions. Start by placing the tail vector A at the origin of the coordinates. So I'm going to take A. I'm just going to move this right here. All of them should be perfectly box length. So even though there's a little space here, don't worry too much about that. Then we have C, which is, we're going to use the tip to tail method or the head to tail method. So I'm going to throw that right there. Right, then we have F, D, and E. F. See, I get this just right. D. And E's going to go over here. Something to keep in mind is, remember, the vector order does not matter. So if I wanted to, let's say I did E first, and then I did D. That's the exact same as if I did D first. So if I take this, move it over, notice how they land in still the exact same spot. So now what I'm going to do from here is I've added them up correctly, and then it says for part 2, move the resultant, the red vector, to correctly display the sum of vectors. And so we're going to take this red one and we're going to adjust it so that we have it starting at the start point and ending at our end point, which is right there. So just for doing those two, you're going to be getting 7 points, so that's easy. We go to part 3. What is the resultant length? Well, this is going to be where we need to use Pythagorean theorem, but what we can do is we can actually draw on this. So I'm going to go to my draw function. We'll use something that's easy, purple. So we're going to go over right here. So this is about 4 boxes, and it's horizontal amount, and then we go right here. And this is 1, 2, 3, 4, 5 boxes. Right? So if we ignore, right, we don't even need these right now, right? These are unimportant. On yours, please don't delete them, because then I won't be able to know if you added them up correctly. But so now we have this horizontal one, which I'm going to color in a little bit better, and this vertical one. And if you notice, of course, this makes a right triangle. So what we're going to do is we're just going to use Pythagorean theorem. So we have 5 squared plus 4 squared, and we're going to take the square root of that. So we have 25 plus 16. Which is, what is that, 25, 35 plus 6, 41. So we get the square root of 41, and if I break out my calculator really quickly, that gets us, let's see, the square root 41 is equal to a resultant, which is 6.4. So, and we want to do units, so boxes. So if we go down here, we have 6.4 boxes. So then we have this next part. It says, let's say that this was a map for which one box represented 7 miles. How many miles does the resultant represent? So we're going to write down what we have. And we're going to use our conversion factor. Right? So we have 1 box equals 7 miles. Right? I'm going to turn that into a fraction so I can get rid of the boxes. So I know 1 box is the same as 7 miles. And so it's really just 6.4 multiplied by 7. Do that really quickly on the calculator. That gets us 44.8 miles. So make sure you have that unit or else you'll lose some points. So this is how we add vectors graphically, right? You're going to be able to use your the graphing paper to kind of like put it together and construct it and just move things around. For now, we're going to do using the algebraic method, using the mathematical analytical method. So right here, we actually have the exact same vectors that we had from before, but mine are deleted. So that's kind of sad. I'm going to have to press or undo everything that I just did in order to get those back. So let's do that really quickly. So we had, right, A was first, and then we went in order essentially. So A, right here, so I'm going to label them so that you guys know too. We have A, C, this was D, this was, actually I think this one was E right here, and oops, looks like this one was F, this one was D. Okay, so now we have them labeled. So we have A, if we look at A, well first we want to choose some positive directions. Let's say that this is going to be positive, so it's going to be a positive X, and up here is going to be our positive Y. So our A goes to the right, so that's positive 2. Remember, put that in, positive 2, and then it goes up 3. And that's going to be in our positive direction as well. We go to C. C goes just to the right 3. It doesn't go up at all, so it's just 0. F, it actually goes horizontally in the negative direction 3 units and up 4 units. And this is a positive 4. Next we have D. It's -2, -2. Right, and just to kind of reiterate, right, we actually just broke that down. That's a -2, and that is a -2. And then E is just a -4 in the X direction. No Y direction at all. So what we can do is we can add up these columns. So I have 2 plus 3 is 5, minus 3 is 2, minus 2 is 0, minus 4 is a -4. And we get our Y component, 3. Plus 4 is 7, minus 2 is 5 in our positive direction. Right, so this is plus 5 in the positive Y direction, -4 in the X direction, right, negative X direction. So if we look back at our resultant, that's exactly what we had. Well, we had 4 boxes right here in the negative X direction, and we have 5 boxes in the positive Y direction. So this is good. It's adding up to the same thing essentially. Calculate the length of the vector, and we just take these, and these are our components essentially. So just to redraw it, just to make sure we're doing the right thing, we have a -4 here, and we have a positive 5 here, and that gives us a resultant just like that. This is our R. And so again, we do 5 squared plus 4 squared, and we already know what this is going to equal, our resultant, which I believe was like 5.8. But just to do it again, because I deleted it, we get the square root of 41. And that gets, 6.4 boxes. And so that was the exact same as our 6.4 here. Finally, says use component addition to add B, D, and E. Make your own chart. So what I'm going to do is I'm going to write my vectors down. I have B, D, and E. And then I have my X direction, I have my Y direction. And now I'm just going to do that one again. And we have also our resultant here. So D and E we actually already know. D is not going to change, it's -2, -2. E was just a -4, 0. B is new, so we go back up to it. B is a +1, -4. So we're going to add all these up. We get, this is -6 right here, and then plus a 1 is a -5, and then here's just -6. So if we were to do this, it's just going to be something that goes like that, and something that's even longer that way, and our resultant would then be something like that. We have 5 here, we have 6 here. Technically negative, but these arrows mean our direction. And then we're just going to use Pythagorean theorem. So we have 5 squared plus 6 squared, and we're going to take the square root of that. That gives us 25 plus 30. And then that gives us the square root of 55. Using my calculator, that gets us a 7.41 boxes. And why don't we check that really quick? Let's make sure it actually looks like that. So let's take B, D, and E and do them here. So I'll take B. Put it here. I get D. It should have been just like that. My B is a little bit off. It should be like that. And then we get our E, which is right here. We get our resultant, which is this guy right here. And we look at what we got. So we got 5 boxes in the negative x direction, and then 1, 2, 3, 4, 5, 6 boxes in the negative y direction. We look down here, and that is exactly what we got. So awesome. We're good to go then. So if you have trouble with this worksheet, please let me know. Again, you're not actually finding the total resultant, you're only finding the magnitude of the resultant. We will talk about different directions and things later on. So I hope this was helpful. If you need any help, please let me know. Also remember that this specific worksheet is different from the one you are about to do. So that's all for now. Have a good day.